Okay, today we're going to talk about finding slope from a table. So we've already learned how to find slope from a graph, rise over run, or the change, can we see that? No, we can't. The change in y over the change in x. So we relate how does y change, and y is our independent variable, and x is our dependent variable. So y depends on x. Okay, so we have already figured out how to calculate slope on a graph. You would do rise over run. So like looking at this graph, we have these 2 points right here, and our slope is 1 over 1. 1 over 1, and our slope is 1. Now, we also know that 1 is our slope because when we're looking at this equation, y equals x, the x right here doesn't have a coefficient in front of it. And so when something doesn't have a coefficient in front of it, it automatically means it's 1. We just don't include it. There's no difference in saying I have a dog versus I have one dog. They mean the same. In math, we like to drop unnecessary things. We also know that the y-intercept for this equation right here is 0. We can see that on the graph. It starts here at 0. And we don't include 0 because adding 0 does not change the value of something. And in math, we like to keep things as simple and neat as possible. So I'm going to use this graph and equation because I want to plot some points that I see. So I know I have 0, 0. And I've got 1, 1. And then as I go up my graph, I notice I have other good points. So like 2, 2 is a good point, 3, 3, 4, 4, 5, 5, 6, 6. So 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Okay. Now, sometimes all we're going to get is a table. That's all we're going to look at is a table. And from that table, we have to determine our slope. Okay? We already know this is a linear equation because we can visually see that. But if we just have a table, we're going to have to determine whether or not something is linear based on the table. And by linear, it means that it creates a straight line. And if it creates a straight line, that means the slope is consistent throughout. So how do I find the slope if I am looking at a table, and just a table? We already know the slope is 1, so we're going to prove that it's 1. In order to find the slope, I calculate the difference between the points. So the distance between 0 and 1 is 1, and the distance over here is 1. And then what is the ratio that is created with these two? So this would be 1 over 1, which is 1. And I keep going throughout my table, so between 1 and 2, 1, 1. 1 over 1 equals 1. 2 and 3, 1, 1. 1 over 1 equals 1. So I know what I've got thus far is linear. What happens, though, if my points aren't in order? So I'm going to show you what would happen if I compared 0 and 6, 0 and 6. Okay. Well, from 0 to 6 is 6. From 0 to 6 is 6. 6 over 6 is 1. So we know it's linear. They are proportionally the same. 2 over 2 would also equal 1. It's all about being proportionally the same. So we calculate the slope by comparing numbers within the table. We're going to practice a few more. Here we have another equation with far less points to choose from. So I have my point here, my y-intercept of 9. and my slope was negative 1/10, so I went down 1 and over 10 to get this point. And then my only other good point is this point up here on the graph at negative 10, 10. Now, if I went down 1 over 9, or sorry, down 1 over 10, I'd end up back here where my y-intercept is. So this is a straight line, but we're going to prove that by proving that the slope remains consistent. So let's imagine we were just given a table, and these were the points that we had. 0, 10, negative 10, 9, 8, 10. And this should actually be, no, we're good. Okay. So let's start calculating. The difference between 9 and 8 is minus 1. And the difference between 0 and 10 is plus 10. And remember, slope is y over x. So we have negative 1 over 10. That's negative 1/10. Okay? Well, the difference between 8 and 10 is positive 2. But the difference between 10 and negative 10 is minus 20. So I have 2 over negative 20, which is also negative 1/10. So these are the same. We find the slope by calculating the distance between 2 points on our table. Okay, so we're going to find the rate of change based on the table. Rate of change is another way of saying slope, and we're going to write that rate as a unit rate. Unit rate is another way of saying slope. So I'm going to, let's see, we have number of balloons and we have total cost of balloons in dollars. So the number of balloons is my x, that is my independent variable, and the total cost is my y, that's my dependent variable. So I'm just going to write this in here. So 2, 4, 6, 8. And let's see, 6, 12, 18, 24. X and y. Okay. We find the slope by comparing two numbers with each other within the table. So I'm going to compare the 6 to the 18 and the 2 to the 6. Let's see. From 6 to 18, that is 12. Remember, slope is change in y over change in x. So we have 12 over, from 2 to 6, that's 4. 12 over 4 is 3. Okay, let me compare two other numbers. Let me compare 4 and 8. So 12 to 24, that's 12. 4 to 8, that's 4. That's also 3. Okay? Well, let's compare 6 and 12 and 2 and 4. 6 to 12, that's 6. 2 to 4, that's 2. And 6 divided by 2 is 3. So the slope here is 3. And in this case, it's $3 per balloon. So we're going to look at these two tables that are given to us, and we're going to calculate the rate of change between the points listed in the table. And we're going to determine if the table represents a linear relationship. So we're going to start with 7. Remember, rate of change is another word for slope, and slope is the change in y divided by the change in x. And in order for something to be linear, it has to be constant throughout. The slope on a straight line stays constant throughout. So, let's start calculating. We're going to calculate the difference between 35 and 14 and between 5 and 2. So this is 21. And this is 3. And 21 divided by 3 is 7. And let me do 2 more points. So I'm going to do the difference between 35 and 70. That's 35. And 5 and 10, that's 5. And 35 divided by 5 equals 7. So right here we have a linear equation because the slope is 7 and that slope stays consistent throughout. Let's look at number 8. The difference between 50 and 10 is negative 40. But the difference between negative 10 and negative 2 is positive 8. This is where integers are very, very important. So negative 40 divided by 8 equals negative 5. Okay, let's find out if that stays consistent throughout. So I'm going to do 10 and negative 70. And I'm going to do negative 2 and positive 14. Okay, so the distance between 10 and negative 70, that's negative 80. And between negative 2 and positive 14, that is 16. And negative 80 divided by 16 is also negative 5. So this is a linear equation because the slope stays consistent throughout. We're going to look at these last 2 tables to determine both what is the slope and do these tables represent a linear equation. Remember, once again, slope is the change in y over the change in x. It's a constant rate of change. In order for something to be linear, the slope has to remain consistent. So we find the slope in a table by finding the difference between 2 sets of points. So between 48 and negative 24. So from negative 24 to positive 48, that is 72. And from negative 1 to positive 2, that is 3. And 72 divided by 3 equals 24. Now let's see if that rings true throughout the others. So from 48 to 90. 90 minus 48, that is 42. And from 2 to 4, that's 2. And 42 divided by 2 is 21. So because these 2 slopes are different, this is not a representation of a straight line. Let's look at number 10. From 12 to 6, that's minus 6. From negative 6 to negative 3, that's plus 3. Negative 6 divided by 3 equals negative 2. Okay, let's see if this is true. From 6 to negative 6, that is negative 12. And from negative 3 to positive 3, that's positive 6. That's also negative 2. From negative 6 to negative 10, that is minus 4. But from 3 to 6, that's 3. And look, we have negative 4/3. Negative 4/3 and negative 2 are not the same. So this is not an example of a linear equation because the slope is not consistent throughout the table.